Some trig limits. F of x equals sine of x. I show this on your packet, but it's worth explaining a little bit. If we want to find the limit as h goes to 0, f of x plus h minus f of x over h equals cosine of x. We want to show that that's true. This is what's called the derivative, and this actually gives you the slope. The slope of the sine function is given by cosine. I'll talk about that in a minute. Well, we start with limit h goes to 0 of this expression. F of x plus h is sine of x plus h, and f of x is sine of x over h. And we have an expansion formula. We've looked at that previously. We can expand that sine x cos h plus cos x sine h, and then copy down the sine x. Now we're going to rearrange the terms. We've had a couple fundamental trig limits before, and we want to rewrite this into the form of limits. So we're going to move, it turns out, we're going to move this over here, move this over here. I just interchanged the terms. Now the reason is here you can see the sine x we can factor out, it leaves cos h minus 1. And it gives us that. And then this over that is that. We're going to break it up into two separate limits. And then limit of the sum is equal to sum of the limits. That's a basic property of limits we looked at previously. And then notice since h goes to 0, sine of x is really a constant. The x is not affected. That's no different than having a 5 here. And since cosine x is constant, the limit's all happening with h, you can factor cosine out as well. And that gives us sine x, limit h goes to 0, cos h minus 1 over h. Same thing, cos x factored out, sine h over h. Now, the limit form we looked at was 1 minus cosine, we got 0. Well, you flip this around, you get negative 0, and negative 0, same as 0. This can be in either order, you still get 0. So we get this sine x times 0, plus this cosine x times 1, that limit was 1, and that simplifies to cosine. That says the slope of the sine function is a cosine. It's really easy to illustrate that, by the way. So you can take a basic sine function, and of course if you graph it, the sine function looks like that, where there's pi, there's 2 pi, and that could be x, that could be y. Well, right here, you have a slope of about 1. Right here, you have a slope of 0. Right here, you have a slope of negative 1. Here you have a slope of 0. And then back here, you have a slope of 1. This is the sine graph right here. Now, if you plot that, right here, if you plot a 1, gives you this point. Move down to pi over 2, we get a 0. Move down to pi, we have a slope of negative 1. And then back to 0. And then at 2 pi, we're back at 1. Okay, well, guess what? Looks an awful lot like a cosine. Not only does it look like a cosine, but we proved it is a cosine. One of your homework problems is to start with a cosine function. And show this process applied gives you the negative sign. So you can take the slope, 0, negative 1, 0, 1, 0, and plot the function. It actually is a negative of this function. You can flip this over, it gives you the slope of this function right here. So and this is part of the analysis you'll learn in Calculus 1, so not a bad idea that you go through it pre-calculus using some of the basic limit information we went through. That's all for trig.